Okay, so I'm sharing my screen. I already we had a class last week with a student in face-to-face class, and uh, I already explained this plan. I wanted to explain it today to you guys how uh, we are going to read the plan and how we are dealing with the sewer system plan. So uh, I'm going to explain everything to you guys right now. You can see my screen, am I right?
Yes.
Yes. Okay, perfect. So this is the street in the city of Fort Worth, I believe. We designed this one before, and they do the construction on that. We wanted to learn how to read the sewer system, water system, stormwater utility system. When we wanted to read the plan for such a this utility in the horizontal construction, over here, over here, always you have what is the dimension of the line. Usually the dimension of the sewer line is 8 inch. We don't go less than that. So 8 inch is the diameter of the pipeline for the sewer system. As you can see, is a state specified, it is wastewater. So another location that you can confirm this one is on the top of that, they said 8 inch PVC wastewater line. So our pipeline is going to be 8 inch. So as you can see, lot 11, 10, 9, these are the houses around this street, which we have a pipeline running through this street. Two things is really important. One is stationing, one is elevation. Stationing, it is at the bottom of this. Okay, station. We have a benchmark. They call it 0, 0. And then we will see the stationing over here. Each of this line show 10 feet. It means from here to here is 10 feet to first line. So then 20 feet, 30 feet, 40 feet, 50 feet. So basically over here, they call it 0, 0 plus 50. It means 50 feet away of our benchmark, the start point. Then 100 feet, then 150, then 200 feet. And they show it 1 plus 0, 0, 2 plus 0, 0, and up to 4 plus 0, 0. Okay? So they call it a stationing. We have another item, they call it elevation. Elevation, it means what is the elevation of the each point above of the ocean. So as an example, if we point this area Basically, this is the ground level. The dashed line mention about the ground level. So this is the ground level in the street. So when we wanted to find out what is the elevation at this point, we call it elevation. And basically, easily we are going to come from here and mention this is 400, 401, 402, 403, 404, and 405. So the elevation is going to be equal to 404.2 almost. So it means this point on the ground level is 404.2 feet above of the ocean level. So why finding the elevation for us is really important, because in this way we know how much earthwork we have and how we should do the excavation and blah blah blah. This circle on the plan, it means manhole. This is the manhole. So always the distance between the manholes, this is another manholes. Always at the 0, 0, we have another manholes. And the distance between the manholes is from 0, 0 to 3 plus 7, 0. So basically the length of the pipeline is going to be 370 feet based on the stationing that we can read. So the distance between the manhole to this manhole is 370 feet. Usually the distance between the manhole is 500 feet. So we understand here all the pipeline is going to connect to the 0, 0 or benchmark. So the manhole at 0, 0 are critical point. And to the right side of this manhole, we are going to develop 370 feet pipeline to connect all the sewer system for these houses to this pipeline. So we connect all of the sewer system for each lot to the main pipeline that we are developing. Another element that is really critical is these arrows. These arrows show us how we should slope our pipeline. When the arrows is in the right to left, it means we are going to slope our pipeline from the right to left. This is the meaning of the slope. So the arrows show the slope of the pipeline. So it means we should slope the pipe this way, from right to left. So after we understand all these things, we can develop our pipeline, then we can find out what's going on or how much earthwork we should do. So as I mentioned, this is our ground level. Always we know we have a manhole here. We understand we have a manhole here. And we understand we have another manhole the other side. What is the information of these two manholes? We can find it in this box. For the first manhole, you can see the station of that, they call it 3+70. The elevation of that, the elevation at the top of the ground is 404.25, which we mentioned. So the elevation at the top of this manhole is 404.25. The elevation on the top of this manhole, how much is it? It means the elevation on the top of the ground is going to be in this box. As you can see, it mentioned 404.2, and the station is 00, which means this is our starting point, is benchmark. So 407.2. Is it correct? We can check it as well. Oh, this is 405. If we go all the way here, from here, yes, it is 406, 407.2. It is accurate. So the elevation on top of the ground is 407.2. It means the surface of the manhole. So we mentioned our pipe going to slope this way. This is going to be our slope of the pipe based on the arrow that we have. So what should we do is now we need to develop our pipeline. How we should develop our pipeline? We know our pipeline is 8-inch. This is almost 8-inch. Always, always, always. If this is our ground level, our pipeline has to be 4 feet below. Always the pipeline shall be 4 feet below ground level for 3 reasons. What is those reasons? Is one, truckload. Two, freezing. Three, moisture is consistent. And less movement of the soil. What does it mean? It means when we have a big truck, when we have a big truck is passing this, the big truck is passing our, um, this is assumed ground level. Ground level. Well, the truck pass on the top of this road, the pipe, it can break if it is very narrow to the ground level. So at least has to be 4 feet. minimum 4 feet. So in this way, the pipe is not going to break. Second, when we put the pipe in 4 feet deep, the freezing is not going to bust the pipe. Third, the moisture is consistent. The fat clay, based on the fat clay, if you have a movement on the soil, is not going to break the pipe. So for this reason, always, we put the pipeline minimum, could be more, but minimum 4 feet under the ground. So when we wanted to lay out our sewer system, we are coming 4 feet down, and then we know where is our uh, elevation on the top of our pipe and where we are connecting the pipe to the manhole. So basically, each of them, each of these number is 1 feet. So this is, if we come down from 404.25, 4 feet down, then the elevation on the top of this is going to be equal on the top of the pipe is going to be the elevation on the pipe is going to be 404.25 minus 4 feet is equal to 400.25 feet above of the ocean. So basically, this is our elevation for top of our pipe. Then we know we slope the pipe from right to left. So basically, we are going to slope this pipe from right to left. And assume our slope of the pipe is 1% for this example. Now we know the top of the elevation on the top of for the pipe at the right side. We need to find out what is the top of the elevation for the pipe in the left side. How we should find out and how we should find out where is the right location for this. So basically we know the top of the elevation on the right and we know the slope is 1%. What is the math for that? So if we have 1% slope and we know this length is, as an example, is 50 feet or 100 feet. We can make this one longer. For when the slope of the pipe is 1% and we run it 100 feet, how much drop we will see? What is the drop over here? Any idea? Is going to be 1% of the 100 feet. It means every 100 we will see the drop 1 feet. Clear? So basically for 370, because this is 370 at this point, 370 station. Up to 00, we have 370 feet. So how much drop we will see over here? Basically, we are going to see 3.7 feet drop from the right side to the left side. Why? Because, so I'm going to write this one. If this one is going to be 370, our drop is going to be 3.7 feet. So if our drop is 3.7 feet, so it means the top of the elevation is 400.25. So the top of the elevation on the top of the pipe in this location is going to be 404.5 minus 3.7 feet. So the answer is going to be 396.55.
Dr. Poirier,
Yes,
how did you find the slope of the pipe?
I define it.
Oh, okay, okay.
I define it with what is the slope of the pipe. So 396.25 is going to be here. Basically, this is 395, 396.55 is here. Do you agree? So in this way, we find out how we should lay out our pipe. It's not difficult. The reason is you are going to see engineer is going to give you guys. I'm just trying to show you guys how you are going to deal with that as a contractor. I will explain it why we develop everything here. So far, any question? Okay. Now, what is important for us? The important for us is find the total excavation because we need to excavate everything and put this pipeline. How we should find that number? So basically, we are going to do two things. Let me move this. So now we assume, let me put this one assume, going this way. We usually have a sewer system a slope between 0.5%, 1%, 2%. So 1% is a reasonable slope for the sewer system. So now we wanted to know how much excavation we should do. So how we find it, we wanted to create a trench at this elevation. When we create the trench, this is going to be our trench. This is going to be our trench. Let me develop the trench. We are going to have a trench here. This is our trench in this location, and we have a trench. I'm going to try to have a trench in the beginning as well. Now, in the middle of the trench, we are going to have our pipeline located. So we know our pipeline is 8 inches, am I right? The diameter of the pipeline is 8 inch. Agree?
Yes.
So pipeline diameter is 8 inch. Then always the width of the trench is between 4 feet, depends, to 6 to 8 feet, but depends, but very common is 4 feet to 6 feet. Uh-oh. Now, always we put the select soil. Select soil is consistent, the gravel, a very small particle that they are going near each other. So this is our select soil material. It's going to be kind of select soil, gravel, and blah 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 to make sure we don't have the displacement and we don't have a drainage issue. And usually this part is 6 to 12 inch. This is 6 to 12 inch. Now we know this height, we know the other height, we know the width of the trench. Now the only thing that we need to calculate, how much is the room from top of the soil. This is the ground level. This is ground level. So we need to find out what is this gap. How we find this gap is we already find it. We know this is the ground level. This is top of the soil. The difference between the top of the elevation of, sorry, the pipe, the elevation on the top of the pipe and the elevation on the ground, top of the ground, the distance between these 2 points is this number. So this number is equal to, I call it H1, is equal to 407.2 minus 396.55, which is equal to, is going to be 310, 10.65, I believe, feet. So 407.2 is the top of the elevation on the ground. 396.55 is top of the elevation on the pipe. So we minus these two, and our number is equal, this is 3.45, is going to be 10.65. Am I right? So we should do the same calculation for the other one, for the beginning. Actually, let me do this and copy this. I delete this.
Hey, I'm just kind of jumping in here, but I want to first say that I have a full-time job. I don't know about everybody else. And Puya, I know we have a good rapport, but I can't be present at meetings that are set and scheduled at 6:30 and 7 p.m. on the night before for the following day at noon. That doesn't work for me on my schedule.
I understand, Paul. I'm sorry for that because you couldn't attend to the class and we need to explain it. Based on that, I said I'm recorded everything and you can check it later. Just I
Okay.
wanted to explain it if you are available.
Yeah,
Okay,
that's
I'm
fine.
going to post it in the Canvas as usual. Whenever you have a time, you can check the video.
Let me ask you this while I have you on here real quick, because I just wanted to jump in and ask a few questions while the class is available here. But all this stuff then is being recorded, so I can go back and reference all of this.
Yes,
Okay, perfect. And then this is pertaining to the project that I saw today. Same thing. I mean, I just saw this morning, but so we have a project now that's due, and then our midterm is next Wednesday.
this is the project that is going to count as a midterm exam for you guys. Yes,
Okay, so the project will be the midterm then.
yes.
Perfect. Okay. I'll stay in this session then for the remainder of this, and then Puya, I'll connect with you after class. I appreciate it. Thank you.
No problem. I'm not. We can discuss again next week whenever you
Okay.
are available during the lunchtime. If you have questions, we can meet and you can ask.
Okay. Thank you very much.
Sure, no problem. Okay. So the trench at the beginning, we are 4 feet down from the ground level. The pipe is consistent, the diameter of the pipe. The base of select soil is consistent, 6 inch to 12 inch. The trench width is going to be consistent. So we find out where we are going to put the pipe. Now, after this, we can easily find out how much excavation we should do to put this pipe down. So the equation for the excavation is going to be the volume of the excavation is going to be A1 plus A2 divided by 2 times length of the pipe, or distance between the manholes. So the excavation volume is finding this way. What is A1? A1 is the area of the section at A1 is going to be the area of the section at benchmark. It means 0, 0. So this one is going to be A1. A2 is going to be this one at the 3 plus 7, 0, 0. And the length is going to be between these two manhole distance. So how we find the A1? A1 is easy, the area of this trench is going to be area of the trench at this station. So basically is going to be equal to width. Assume the width 4 feet for this example, and is going to be 4 feet times the height. Assume for this one the base is 6 inch. The total height is equal to 10.65 plus 6 divided by 12. I'm changing it to the feet, plus 8 divided by 12. So then if you add all this number together, it's going to be 1.2, is going to be 11.83 almost. So then we are coming back to the A1 is going to be 4 times 11.83 is equal to almost how much is going to be 4 times 11. It's going to be 47.32 square foot. So this is going to be A1. Now, same thing we are going to do for A2. A2 is the trench at 3 plus 70. Assume again the width 4 feet. Assume the base 6 inches. So the height is going to be 5.2 almost, and the area is going to be 20.8 square footage. So if you put it in the excavation volume, it's going to be equal to A1 47.32 plus 20.8 divided by 2 multiplied by 370. This one is going to be the total volume of our excavation. Is going to be 12,602.2 and is going to be cubic foot. And if we divide this number by 27, we are going to have 466.75 cubic yard excavation. Any question? So I put this one in the canvas. I wanted everybody start to doing one by one, whatever I asked you guys, and create all the calculation for me and submit it for the project number 1. So whatever we discussed, is for the right side of the benchmark 0, 0. Now we have, this is the longest tree. In the left side, we have a pipeline which is connected to this one and is going to be here. So we have a same scenario. This is our station 0, 0. We have the manhole here. And we have another manhole at the station 6, 3 plus 6, 0, which is going to be here. And we are going to develop that one too for the project. And as you can see, the arrows is opposite way. So the slope is going to be this way for the pipe. So we have a pipe that which is a slope the other way. And then for you guys, these two is good enough. You don't need to take care of the last sheet.
Dr. Poirier,
Yes,
can you post a snapshot of the example you just did so we can reference it?
I'm going to post it in the canvas
Okay,
and I'm
thank
going
you.
to submit everything in the canvas.
Okay, thank you.
I already saved it. I already posted in the canvas. Okay. So for this part, what you are going to do, again, from here, you are going 4 feet down. From the you are coming down 4 feet. 1, 2, 3, almost 4 feet is here. Then you develop pipeline and find all the elevation. So basically, after you come 4 feet down, find the elevation and 1% you use and going up. And in this way, you understand how much excavation you should do. Feel good? So
Yes.
basically, 2 sheets you are going to do. In the face-to-face class are going to be 3 plans, but for you guys, it's going to be 2 plans, and I will explain it later to others. So I'm going to save all this in the canvas, and I'm going to put it over there. I will be available on Monday at noon and Tuesday at noon. So in this way, if you have any question, please start it and ask me all your questions. So please review everything during the weekend, and we can work on that during the Monday or Tuesday, your lunchtime. Sounds good?
I just have a question.
Yes, sir.
Do we just choose whichever 2 plans that we want to do it and the questions as well?
One more
That
time,
we
sorry.
want Do we just choose whichever 2 plans that you submitted, and then just figure it out from there?
Yes, yes, I'm going to submit. You have a blank of that, and I'm going to submit all the notes, and you are going to do exact these 2 plans. I give you guys different slope, and you are going to do that. Actually, it's better that you do the last one as well. Again, over here, you have another manhole. I'm going to explain it later to you guys. I wanted you guys try the first 2, then I'm going through this later, and you will complete the project. It's too
Okay.
much right now. I mentioned that, but first you are going to start the plan in the right side of the 0 plus 0 and 1 plan in the left side of the 0 plus 0.
Okay, sounds good.
Yeah, I don't want to load you guys too much. Slowly we are going through that. So if you don't have anything else, I don't have anything for today. And this project has another part, which is going to count for your excavation as well, to find the concrete for the um, pipeline, which I will discuss about that later. Sounds good?
Yes.
Basically, what I'm teaching you guys is a combination of the estimating and horizontal construction. So in this way, cover for both of them.
Do we still have to meet tomorrow morning?
No, as I mentioned 2 days. So if you are busy today, you can meet with me tomorrow.
Oh, okay. Okay. Thank you.
Mhm. Okay. Thank you, guys. So let me put this one in the canvas, and I think we are good to go.
Thank you,
Thank you,
Dr. Poorya.
Dr. Poorya.
Sure. Have a wonderful day.